Okay, this is a test of concept, it would appear, with something called screen castomatic. And what I'm going to do here is show something for my daughters who are in 11th grade and in 8th grade, something to do with a piece of software that is on all apples, the original software being the original Apple grapher. Go out and check out the story at This American Life. What I'm going to show here is the power of using parametric equations as early and as often as possible so that you can then start working with matrices in a two-dimensional plane. I'm going to do that using the Apple grapher here and recording on this proof of concept. My microphone looks like it's a little iffy, and I'm probably not going to update that, so we'll kind of go from where we are. All right, so what I'm going to do right away is originally just put in what we might teach in math class, which is y equals x squared. Gives us that. Of course, we know, of course, the inverse function of that is x equals y squared. And in the end, we'll also know I'm going to go and add right now, I'm losing some of the possibility up above here because I've taken my screen here. I'm going to go up and add equation, new equation, and add basically x equals y function. So one can see that these are actually interesting how this crosses that line, but it does. And I'm going to go once more time and set equation and new equation and then add back what is y equals x squared. Now what students are learning with this inverse function concept is, amongst other things, that these functions are reflected about a line of 45 degrees, which is well and good, but pretty limiting in terms of which way that parabola is going to face. So good important concept, but because of the avoidance of just the most simple of transformation matrices, we lose the fact of the ability to kind of reflect, if you want to call it, any function about any line. And so let's go about erasing these and going backwards, and we're going to go ahead and do that and turn these off. Okay, and turn that off, and in the end I think I can say equation, edit, cut, edit, delete. And here I'm going and saying edit. You don't see those from up above, but that's fine. And edit, delete. All right, so now what I'm going to do is going to put this in a parametric format. I'm going to go to equation, new equation. I'm going to go ahead and put that basic equation in a parametric format. Looks something like this. First thing, I've got to get rid of that because it's not going to be a y equals, it's going to be a vector, an xy vector equal to, and in this case we're going to once again put this as a question of time, which is very typical. In other words, if you're using time as the parameter, you get a sense of not just the parabola, but the parabola at any point in time, and this is t squared. So in this case, you also have to tell it t equals maybe minus 5 to 5, dot, dot, 5. Okay, and you have that equation. That's all well and good. Here's the rub, however. We can now also then to this function add a transformation function, which comes in the form, in this case, of a 2 by 2 matrix for a 2D plane. For a 3D plane, it's going to be a 3 by 3, but of course we do a lot of 4 by 4, basically an augmented matrix, so we can both do our transformations that are rotation, reflection, shearing, and translation, which is not a, I think it's not a linear transformation. So that said, I'm going to add to the front of this, see equation palette, I'm going to add, you're not looking operators, I'm going to add a 2 by 2 matrix. And at this point, I'm going to put in cosine of pi over 4. All right, but what we want to do is we want to do cosine squared, sine squared, sine squared minus cosine squared. So I'm going to see if I can do that most. That's cosine squared of pi over 4, sine squared of pi. Got to bring this down. Like anything, it takes a little bit of getting used to. Pi over 4. You see it's immediately knowing what I want to say and do. Sine squared of. You're also seeing here how important I think it is, and I am nobody, I'm just a dad. It is to teach kids immediately not just degrees but radians. So I'm at 540 here. I'm going to see that stuck up to there. I'm going to go squared. I take it. I'm hitting the down key back over, and I'm going to say pi over 4, and this is then minus cosine squared. Now, again, this is predicated perhaps on some crazy wild stuff that I had in 7th grade in the Chicago public school system. Not all of it, but the concept of sines and cosines. But what was missed through almost an entire engineering career, probably I was out looking at, I don't know what I was looking at, was the fact that as important as the definition of SOHCAHTOA is the fact that cosines and sines travel in packs. The two important packs are cosine minus sine, sine, cosine. That is a rotation. And then cosine 2 theta, sine 2 theta, sine 2 theta minus cosine of 2 theta. So what I've got here is wrong. I'm going to take that square out. I'm going to take that here and say 2. And I'm going to say, I think that should work. And I'm going to say here, and that's recollection, and 2. So it's cosine 2 theta, sine 2 theta, sine 2 theta minus cosine of 2 theta. And if you're curious about that, go look it up in Wikipedia in your transformation matrices or on Wolfram Alpha. So that was one of those that two patterns. One is cosine 2 theta, sine 2, cosine 2 theta, sine 2 theta, sine 2 theta minus cosine 2 theta. That is the reflection pattern that we're trying to do here. And the other one is cosine theta minus sine theta, sine theta, cosine theta. So we'll talk about that later, I guess. We'll see whether this works. We hit the button here, and it does not like it, probably because I have a comma in there. Okay, so still does not like it, and it's really not giving me t comma t equals minus 5 dot dot 5. Now that's not going to be my error, but I think what I screwed up here is probably 2 up on top here. Probably did not like that. 2 pi, and what I'm trying to get is 2 theta here. So later on we'll redo this. We're just checking the screencast. Right, and it also might have a problem with the fact that these are these little boxes up here. Let's see if that still doesn't like it. Doesn't like that. So cosine of 2 theta, sine, go 1 here, 1, 1. See how that works. Okay. So don't screw it up when you start. We have a transformation matrix there. Still has a problem with it. Let's see. Cosine, now we're now at 10 minutes. You'll now see later on, this is where some of the editing would come in. Let me see how that works. T and t squared, t from minus 5 to 5. Is it 3 dots I need? I don't think so. So let's just try this. Cosine of pi, sine minus cosine pi and see how that works. All right, well, don't know. I am going to finish this up and figure it out later. I've done this about 1,000,000 times, and this is one of the beautiful things about playing with software. However, we'll look at the screencast of this, and then I'll come back later and figure it out.